Well, hello and welcome to another DevNation Tech Talk. We're live today coming from both the Westford, Massachusetts area, that's where Ted is today, and I'm still in the Raleigh, North Carolina area. So we're going to be broadcasting live. We're going to be bringing you guys some great stuff today because what we're going to be talking about is a new technology called Skupper that Ted's going to introduce us to. But more importantly, he's got all the clouds happening right now. We're live today coming from... Oh, man, and I've got a feedback loop here I got to deal with. Let's see. There we go. Okay. So even when you mute the thing, it still wants to come back at you. All right. So at this point, Ted, let's get going.
All right. Thanks, Burr. Hopefully everybody can see my screen going. So like Burr said, we're going to talk a little bit about multi-cluster Kubernetes and doing some hybrid cloud stuff with a new project called Skupper. And just to tell you what the related projects are, we mentioned the Skupper project, but this is also built on top of an Apache Software Foundation project called Apache Qubit Dispatch Router. This is a fast and lightweight router for the Advanced Message Queuing Protocol, AMQP, but it's not really a messaging component. It is a networking component, and it is a mature project, been around for probably close to 7 years now, and it is in production in a number of places, even at scale. The Skupper project is related to this, but it's really tooling and some multi-protocol adapters that are bringing Qubit Dispatch Router into the world of multi-cloud and cloud computing as opposed to messaging. And it's not a mature project. It's in the prototype stage, and it's under active development. And I'm going to give you a demo of what we're doing today. So to begin, I've got 5 Kubernetes clusters running that I've got set up before the demo. So I've got one that's running OpenShift version 4.3. It's running on a set of VMs over at AWS. I've got a straight Kubernetes cluster running on Azure Kubernetes Services. Another one running on Google Kubernetes Engine, and these are all in public locations. And I've got a private one in our Red Hat's lab down in Raleigh, Durham, running an old version of OpenShift version 3.11, and I've got Minikube running on my laptop. So these are the 5 clusters that are all disparate that I'm going to be using Skupper to hook together. So now I'm not going to be using anything fancy. I'm not doing anything with networking. I'm not doing anything with SDN. I'm not creating any tunnels. This is all just user space that any developer can do. All I need to do is have access to these clusters. So I'm going to just show a few slides just to provide context, just so that, because sometimes when you're looking at multiple clusters and lots of windows, it's hard to keep track of what's going on. So here's just a quick rundown of what I'm going to show you. So on each of these locations, I am going to run the Skupper init command, and I'm going to provide an identity that just says, which location is this. And what Skupper init does, Skupper is the CLI that comes with the Skupper project. It is a Go program that you can install. And what it does is it installs a Skupper router in the cluster on which you're running. So we will do this on all 5 clusters. I've actually already set up GKE, so I won't show you that. And then, so the router is then established. And then on the public ones, I'm going to create a connection token for each one of them. That connection token is a YAML file that will be stored, and I can pass that around as a way of getting connected. Because the public access is I need this from the public access clusters because I'm going to need to connect from the private. So once I've done that, I will then create some connections between the 3 in the public cloud, and then that will create connections upwards from my edges. Now, it's important to point out that the Minikube and the RDU clusters they're essentially headless. They don't have any routes. They're not routable to. They have no public address. There's no way to reach them. They're on private IP networks. But once these connections are established outbound, you can see the arrows indicate how the connections are established. Who is the connector and who is the listener. Well, once that's done, those arrowheads don't matter anymore, and we have a full bidirectional network. And you'll notice also that it's not in any particular topology. There's redundancy, which we recommend. So then you can, if one of these public clouds fails, then there's still connectivity between everything. And sometimes it takes multiple hops for things to get places. So once that's done, and I guess what I'll do now is I will run over to my terminals. So I've got a terminal for each of these, and I'm going to run the init on each. And what this does, as I mentioned, is it installs Skupper on those namespaces. So if I were to have a look at so what pods are running, I've got a couple things going on here. I've got a proxy controller, and I've got the router that I mentioned before. Okay. So I will go to the AWS now, and I will create a connection token. So that other things can connect to me. And I will do the same thing on AKS. And I've put these files in as YAMLs in my home directories. And then once that's done, this RDU system is a remote system. I'm actually SSH'd over to that system from my laptop, so it doesn't have these files. So I will have to copy them there. I'll use SCP. Copy all my YAML files and my tokens over there. So what we've done is, in order to create this network, Skupper has a set of utilities that makes it easy to build these networks. And we do it in two places, by creating tokens and then by connecting to those tokens. And this creates a secure network. So I'll go to AWS, and I will Skupper connect to my GKE, and then I will do the same, AKS, and then I will go to the AKS to complete that circle that we had, that triangular cycle. AKS goes to GKE. Everybody following all this?
I'm following.
All right, good. That's the problem when you have this many things. There's a lot going on. So I'm going to do a Skupper connect my RDU to the GKE. To the AKS, and then from my mini cube. This will complete the AWS GKE. So let's see what we've got. So if I were to say Skupper status, it'll give me kind of a quick rundown of what's going on. And what it's saying is that it's enabled in my namespace that I'm running as a default namespace. And it's connected to 3 other sites right now, one indirectly. And I think, since it sometimes takes time for all these things to hook up, now this is actually what I expected to see. It's connected to 4 other sites, 2 indirectly. So, and now if I were to ask AWS, same thing, it will hopefully also be connected to 4 other sites. The fact that it's saying 5 probably means that there is something in flight that's changing around, because there are only 5 sites. But AWS, so Minikube, said it was connected to 4 other sites, 2 indirectly. So what that means is, it's got these 4 other sites, but 2 of them are indirect, because AKS and RDU are not directly connected to Minikube. It's still reachable, but there's no direct connection there. And what's very significant here is that Minikube and RDU are both in private edge networks. They can't make TCP/IP connections to each other necessarily. They might even be in overlapping IP networks, but over this Skupper network, they do have access to each other indirectly. Now, the next thing I want to show is that now, when I created the init on my Minikube, I actually used an option called Enable Console, because we have a console that will then become exposed and can be used. And if this console is available, it makes things much easier to see. So let's go over to that. Let's go over here to Cube. Say kubectl get services. I'll try to spell it right. And I have a service called Skupper Console address, so I will copy that address, go to my web browser, got the console up here, plug that address in, and I will have my console running. And so this is what it's actually seeing. So now let me turn that traffic off for now. So I've got my Minikube running here. Got my AWS. We'll try to set it up similar to the way I had it in the slide. AKS is here. GKE, this is my little triangle of public. And RDU is over here on the other edge. So you can see that this is actually built the network that we expected to have. And that's a good sign. So now that we've done this, let's go on to the next step. So I'm going to go back to my slides and just show what the next thing I'm going to do is. And this is really where the interesting magic happens. So here's where Skupper is giving us a really nice integration into Kubernetes. So I showed you the console hook in. What I'm going to do now is I'm going to create a vanilla kubectl. I'm going to do create deployment. I'm going to put up a deployment of a workload. I'm going to put one in my Minikube. I'm going to put one in AWS. And I'll just give you a quick, I'm not going to spend a lot of time on code, but because this, we do talk a lot about Java microservices and, being able to deploy Java in cloud-ready ways. This microservice is actually written using Quarkus and a little bit of Vertex, and it would be a very straightforward thing actually, except for one change that I made. And so it's set up on a path. It's just /hello, and it's just going to return a little string saying hello from a particular host name and how many count. What's the count that's been done. And this could be done very simply in a synchronous way in a very few lines, and you can find that example at the Quarkus website. But I made it a little bit more complicated by going to a completion stage and going asynchronous because I want this thing to run slow. I want to be able to control the rate at which this can handle requests. And I've got it actually set so that it'll only handle 10 per second maximum. And the reason for that is because it makes this demo more interesting. So what I will do is I'll go back to my my terminals, and when I put these deployments on, I'll just start first with a deployment on Minikube, and then I can use Skupper to expose it. So if you did a kubectl expose of your deployment, you would get a service with an IP address that you could then use to load balance across that deployment. But when I use a Skupper expose, it's going to create that service, but it's also going to create that service everywhere else in the network. So that service is going to appear in all the other clusters as well, even though there isn't a. And that means that from RDU, I can access that service and use that deployment. So that's the claim. Let's see if I can demonstrate this to you. So over at my Minikube, I've got it's the long way. Ctl create deployment. I will call it greeting deploy, and I'll grab an image which is on quay.io/Ted_Ross in my area, and it's called throttle service JVM. And the reason I call it throttle service is because of the fact that I want it not to go so fast. And it already exists. Not funny. So if I do a kubectl get pods, and there it is running. Get services. We did this before. And there is no service for it. So it is just a pod running in a deployment, and it's just sitting there minding its own business. So I'm going to say let's see, get services here. I'll do the same thing some other places as well. And you'll see that I'm just doing this to show you that I'm not pulling a fast one on you. I've got some Skupper services running. I've got Skupper services. I've also got a load generator over here, which I'll use in a minute. So now that I've got this deployment sitting there, I am going to Skupper expose that deployment. Skupper expose the deployment that I created. I'm going to tell it what address I want it to be exposed on. So I'm going to have an address called greeting. I'm telling it that it's an HTTP and I want it to be exposed on port 8080. So when I do that and I go look at services, like you might expect, there's now a greeting service address at port 8080. What you might not expect is for something to happen on these other ones as well. So here I've got a greeting service that's on a port, on an IP address, and over here I will have one as well. So let's go look at the pods. So greeting deploy is this pod. Its name ends in VTW7V, and I am going to curl it from here. So I'm now on the RDU cluster. Curl this address for 8080, and like I showed you in the code, it wants to be talked to at the URL hello. And I got an answer. So it's a greeting deploy VTW7V. So this is actually being answered from the pod that's running on my Minikube on my laptop, but somebody from the cloud out in the world is able to access it. Now, if I do if I set the load of my load generator here, I'm going to actually see that it's running. So I've got a load generator that's creating some requests about as fast as they can go. And now let's go over to the console. See, stay in there. Have a look at the traffic. So what you actually see, and this animation is showing you actual real data from the network. I'm hoping that this comes through over the webcast as clearly as I can see it. But what it's showing is traffic flowing from a client using RDU. It has to take a hop through GKE because there is no direct route between these two clusters. So it's being routed by the Skupper network to the place where it needs to go. Now I'm going to do the same thing on AWS, where I'm going to create this deployment. And I'm going to expose this deployment for 8080. And I don't know why I'm having errors with the console. But I will do this differently. Come on. So it wouldn't be a proper demo if something didn't go flaky. Okay. Well, I'm going to go have a look at links. This is a Cupid dispatch console, so this is really a console that's a little bit more low level. It's not a Skupper console. We are developing a Skupper console, which will be hopefully friendlier to use. We're still running. Address. Okay, so this is the address exposed this on, and I can see that the counters are counting. Links. I'm going to filter on that address. Yeah. And so the links are actually the places where my pods are accessing the network. So I have an endpoint here from RDU, and it's coming in, and it's running at so it's running inbound at 8 per second, and I can see that the AWS version now is the one that's actually handling all the traffic. Go here. And we have this looks kind of like a pie chart, but it's actually a chord chart that tells you or shows you what services are handling the amount of traffic at this time. So what I expect to see is, so I've got the red router is MK, and the big one's AWS. And I think we see a little bit of action going on in the NK, the Minikube. And the reason for that, I believe, is that Minikube is the AWS has better performance, and it's also there's probably a lower latency from RDU to AWS. So a couple of takeaways I want to make sure that you see here is that, one is that when I go to this service to ask for help, or ask to access to make an HTTP or a REST request, that it is served from wherever that request is in the network. It could be someplace else on a different cluster, in a place where I can't reach it via TCP/IP. And if there are multiple instances of that service, and my request load is high, which I should increase my request load, then I should see that load will balance. Let me and that is what's happening now. So I've got now 17 per second. Remember, I've got these things throttled, and 9 per second are being handled on Minikube, and 8 per second are being handled on AWS. Hopefully I can show you here. Yes, I can. Okay. So Minikube's handling about half actually now. AWS is handling the other half. If I come to AWS, and let me scale my deployment, and it's called greeting deploy. Let me set the up close to 2. And see, get pods. I've got a second one now creating in my Amazon location. And now I'm assuming that it's now running because I saw that the amount of traffic being handled by AWS just increased significantly. Okay, I think, Burr, I will stop at this point and see if there are questions or any kind of thing I can follow up on.
There are lots of questions, so we do want to spend a few minutes on them, actually. And
Sure.
I want to kind of go back to the beginning and start at the more elementary level, because I think I might have missed it, the audience may have missed it, and that is, how do you get Skupper installed into cluster A, B, C, or D? Like, what do you have to have from a connectivity standpoint? How do you connect to that cluster? How do you have the right privileges to get Skupper installed?
Okay, that's a great question, and one that I think I did gloss over a bit. So the Skupper CLI is a Go program that you can download. So you can pull it into. So what I'm doing in these cases, these are all these 3 are running on my laptop, but I have a Cube config that is allowing me to remotely access these locations, these clusters. This one I'm actually SSH to a different place, and the one that is at Google, I'm actually using their management shell. So I actually uploaded the Skupper executable into this shell so I could control it from here.
Yeah, that definitely was another one, because there's definitely a follow-on question to that one too, related to, well, what about my firewall rules? How do you configure the network between these clusters? What kind of tips and guidance can you give there?
That's another very good question. So remember when I showed you this diagram here, and this diagram shows the direction of connection. So these, my minikubes on a laptop, and I'm in a private network, and I'm behind a firewall. And as this RDU is also in a private network behind a different firewall. But the connections are established upward. So the connection was established from behind the firewall into the public cloud. And so that means I don't need to do anything with my firewall rules. It generally, if it allows me to make a connection outbound, and I really should also, let me go back to the topology view here and show, these are where these connections are showed. These are TLS connections, mutual TLS or mutual certificates. So these are secure connections that are made outbound through their respective firewalls. But once those connections are established outbound, traffic flows bidirectionally over those connections.
And that was kind of the next question: is traffic encrypted between these clusters and services?
Yes, it is. And the way we do this is we actually have a certificate of authority for these routers, so that they are only allowed to talk to each other. So yes, when you do that, you create that token that is a secure that creates the secrets that you need to make these connections securely. So somebody else from outside the world cannot make a connection to this router. And I should make note also that once I've got these deployments and services running, nothing's exposed. All of these deployments are running on private. These IP addresses are all private to these clusters. They're not exposed. There's no routes. Right. Or ingress is required here. The only ingress is to these public routers, and those are mutual TLS.
Okay. A couple other good questions related to, again, kind of related to the same line of thinking here. Is there a single point of failure in this architecture, or, from an HA standpoint, what do I have to worry about?
There is not, and that's actually by design from the get-go. This router is designed like a network router, where it is intended to be multi-site. It is intended to be set up in redundant networks, and it uses technology very much like an OSPF router in the networking world to figure out where the loops are, calculate the shortest paths, and do that all automatically. So in this case, where any of these public, where AKS to fail or GKE to fail, we will have full connectivity for everything that we've shown. Okay.
And then let's see here, something else is kind of important that I want to make sure we cover. And actually this is a good one, this last one from Diego here. What is the basic unit of communication between the clusters? What is the wire protocol, and what are the other communication parameters between the clusters?
The wire protocol between them is Advanced Message Queuing Protocol, AMQP, which is, it was made for the messaging world. It's really not a messaging protocol. It's really a transport protocol that is far more sophisticated than, say, HTTP, because it is, it's multiplexable, it's full duplex. It's got a lot of capabilities with regard to, quality of service, message settlement, and such. But the unit is a frame, much like you would see in a TCP. And it does run over SSL over TCP.
Yeah, okay. And then there was a question that I think is important, and it's related to the redundancy you've shown here, right? The diagram you have showing. Is what about reconnects and how stable is the connection? Will it reconnect automatically? Tell us a little bit more about the load balancing.
Okay, well, the connections between the routers, there's sort of two layers going on here. So the connection between the routers that form the network are resilient. They will, if they fail, they will reconnect. And in fact, that's the other reason why we have multiple of them, because if one goes down and can't reconnect for whatever reason, the other one will just carry the traffic. There was a question about load balancing. That's on a different level. So on a different level, what we did in our case, we've got our load generator was running an RDU, and it's running on deployments in each of these locations. This protocol, AMQP, I mentioned before that it has actual formal notions of delivery settlement. So it actually knows at the protocol level what the backlog of every server is. And this is how it was able to do that load balancing. That's how it knew that when it had a separate pod spooled up in AWS, that it could send more traffic that way, because it's actually using the instantaneous backlog for each individual server instance as a way to decide where to send things to. So it'll send it to server instance that has the lowest latency right now. There's no out-of-band scanner that's seeing, where are things most busy. It's not round robin at all. It's really sending every request or every message to the place where it can most quickly be serviced right now.
Yeah, and I think that's actually one of the challenges. A lot of people, including myself, have not dug deeply into the AMQP protocol and some of the capabilities the protocol itself has for your, connectivity between different points.
Right, and there's so this will be, I believe the stuff's already included in your package, so I don't necessarily copy this down or photograph this, but there is a blog I have called NetProtoTalk, and I actually wrote an article, I think it was back in 2015. There's not a lot of traffic on this blog, but there was one called AMQP as a network protocol, and it kind of answers some of those questions. Like, yes, this thing was written for messaging, but why is it a good transport protocol for networking? Now, if you want to dig deeper into that aspect, that would be a place to look.
Okay, one last question, and we are out of time, but I just saw it come in. Is there redundancy of the routers at the multi-zone level, or only local redundancy to the site where the router is deployed?
It can be either. The way I've set it up here is I've got a single router in each cluster, but you can also scale those up if you wanted to have higher availability locally, but the redundancy is global in this case, because you can see it based on the redundant topology.
Yeah, because everybody's got at least two routes to get to the other place.
Right, and you can set it up any way you want it to be set up. You can give yourself as much redundancy as you want.
And I hadn't thought about that. I've never tried scaling up to 2 pods of the router to give myself additional redundancy at that level.
Yeah, I'm not convinced that buys you much, but it is something. I think maybe in a stateful set where you might have one per, I'm sorry, not a stateful set. The other one, where it's one per. A daemon set where there's one per host. Actually might give you some good scale, because that way you can you'd be always talking to a local router.
Right.
And there are many details here that we could discuss that we don't have time for today.
Okay. And we are out of time, and I apologize that. Though I did have that one question on Kubeflow that I did miss. It's a good point. You pointed out that I did miss it. And I would say from a Kubeflow standpoint, these things aren't related, if you will, right? Because Kubeflow, of course, is how you run TensorFlow and Kubernetes. And as long as it's a Kubernetes service, right, you can basically use Skupper with it. So any service, it doesn't matter what the service is. Well, the service needs to speak HTTP or AMQP.
Or TCP.
It's a different protocol.
There's also TCP support, so anything that, basically anything that runs over TCP can be tunneled in this way. And we're also looking at UDP and other things like, for the future, but we haven't done that. But right now,
I guess we'd have to think about gRPC at some point in the future. Okay.
That's also supported.
All right.
gRPC.
Well, we're over our time slot, but hey, Ted, awesome demo, by the way. I love this demo. Like, I've been hacking on this stuff myself, and I really enjoy working with the technology. So thank you so much for today's presentation. For all of you guys who hung out with us today, thank you so much as well. Feel free to reach out to Ted on his Twitter handle or mine on my Twitter handle. We gave you a bunch of links in the chat, so you can basically find the blog, find out more information about Skupper, the website. All that's available to you there. And you can always email me directly if you need me. I'm just Burr@redhat.com. Thank you guys so much today.